Welcome to qnawire.
All right, so we have a rifle firing a bullet into a tree problem, and then the bullet comes to a halt. However, the bullet was originally traveling at 350 meters per second. It's, again coming to a halt, so its final velocity is zero. Within the bark of the tree, it traveled 13 centimeters. So we're going to call that 0.13 meters. And then the mass of the bullets is 0.18 grams, or sorry, 1.8 grams, but we're going to go ahead and convert that to kilograms right away because we want everything to be in SI units. So part A is asking us what time interval or how long did it take to do this. And so because we don't know what the acceleration is, we're going to use the kinematics equation that ignores acceleration. So that's finding the average velocities and then multiplying it by the time interval. And then we're going to want to rearrange that to solve for the time interval because that's what we're interested in. And then quickly get rid of that final velocity because we just discussed that it is equal to 0. So the time interval is going to be equal to 2 delta x over v naught. And that is going to result in something, but we have to plug in the numbers first. So 0.130 for displacement, 350 for velocity, and then we get that it was 7.43 times 10 to the minus 4 seconds to 3 significant figures. So very, very quick interaction. Whoops, sorry. All right, and then in part B, we want to know what force the tree had to apply on the bullet in order to achieve the slowing down so quickly. But in order to get to force, we first have to find acceleration. So I think that would be easiest to do with not having to worry about squares and all that and square roots if we just use the simple average acceleration equation. So that's this one. That the final velocity is still equal to 0. And so we can solve for the acceleration as being negative v naught divided by t. Plug in numbers, so that's negative 350 divided by the time that we just found, 7.43 times 10 to the minus 4. This is going to be quite big, but we get an acceleration of negative 471,000 meters per square second. So quite enormous. And then we need to translate this into a force. Oh, sorry, I should not have put a box around that because that's not the answer. We can get a force from that by applying Newton's second law. So that is the mass in kilograms. We just found what the acceleration is in meters per square second. So plugging that into a calculator, and then we get that F is equal to 848 newtons, a more normal looking number.